Okay, so let's have a look at the working out for the Q2 median. Okay, so do check off your answer with what's on the screen now. So we know there are 56, so we do 56 divided by 2, tells us we're looking for the 28th value in this case, and that appears in the third group. So let's set up our linear interpolation. So we've got Q2 and 28 in the middle, and then if we look at the third group, its bounds are 20.5 and 25.5. That's the top half of the diagram. And the frequency for that group will start at 21 and will end at 32. So if we set up our working out, it's Q2 minus 20.5 over 25.5 minus 20.5 has got to be in proportion to 28 minus 21 divided by 32 minus 21. If we tidy that up a bit, we get Q2 equals 20.5 plus 35 over 11, which gives us a Q2 value of 23.68 or 23.7 to 3 SF. Next, we'll go through part B to find the interpercentile range. Looking at the second part then, the interpercentile range, if we do 10%, we get 5.6 for P10, which is the first group. If we do P80, we get 44.8, which is going to be the fourth group. We set up our diagrams, and I've done that below for P10 and P80. Okay, remembering the first group we're going to say has got bounds 0.5 and 10.5, and the fourth group has got bounds 25.5 and 30.5. Okay, and I've put the frequencies below that are relative to those groups. So if we go through our working out, see the working out for P10 on the left-hand side, and I've got down to an answer for that one of 9.83 recurring. Okay, for P80, I've done the working on the right-hand side. We get down to 30.42. So obviously the interpercentile range for this one will be 30.42, take away 9.83, okay, is going to be 20.59 or 20.6 to 3 significant figures. Okay, so we're going to move on next now to have a look at 2.4, variance and standard deviation. Okay, so let's start to discuss what we mean by variance and standard deviation. So far in this unit, we've looked at a measure of spread from the median when we've been doing the work so far. Okay, we're now going to start to look at a measure of spread from the mean. Okay, and this is a better measure of spread because it actually uses all the values in the distribution. So remember what we said when we're looking at the advantages and disadvantages of the mean and the median earlier in this unit. Okay, and because of this, it's more widely used. Okay, it's a calculation based on how the values deviate away from the mean. Okay, so it's based on the differences between each value in a distribution and where they lie from the mean. Okay, and it's at its most useful when we've got two or more separate sets of data, so we can actually use the value we get for both of them to make a direct comparison. Okay, so generally the process we're going to go through for calculating the mean boils down to this. Okay, first of all, we're going to work out the mean. Okay, we're then going to subtract the mean from each value. We're going to square these values, because if we didn't square these values, then when we added them all together, we'd end up with 0, because obviously things are will balance out to where the mean is. So we need to make sure we're using the squared values, so we've got something we can work with. Part 4, we're going to add up the squares. Then we're going to divide by how many numbers there are, and then we're going to square root. So that's the process for standard deviation, and it then moves us on to having formulas that we can use. And there are a couple of ways that we can do that, and we'll cover that in the next slide. Okay, so the formulas that we can use in general are as follows. Okay, so variance, and we use the symbol little sigma squared. Okay, is going to be the sum of, as we said before from the previous slide, x minus x bar squared divided by n. Okay, So that's, as we said before, we're going to find how far they go from deviate from the mean. We're going to square the values, then we're going to divide by how many numbers there are. Okay, and that could also be written as big sigma x squared over n minus brackets sigma x over n all squared. You need to think about what an alternative name might be for what sigma x over n all squared is. Okay, and that comes down to when we get down to the user-friendly section at the bottom. Now, there are going to be some questions, everyone, where they may supply something that says SXX, and this is a summary statistic. So what they may do already is actually give you the value for big sigma x minus x bar all squared. Okay, so sometimes it can make the formula easier to learn, but also sometimes you just need to then put that in and calculate your variance and standard deviation. And obviously the standard deviation we're going to use, everybody, is just the square root of the variance. So as you can see, we've got a similar line for the standard deviation, but obviously we're square rooting everything. So you could think of standard deviation as being the square root of the summary statistic SXX divided by n. Okay, as we said in quite a few questions, your first port of call is going to be to find the mean. And if you notice, the second part of our formula, the sigma x over n, is going to be your mean, basically. So we could, as a user-friendly version, we could write standard deviation at the bottom equals the square root of big sigma x squared over n minus the mean squared. And that's probably how you're going to use this for quite a few of the questions moving forward.